Now in this lesson, let's look at prime numbers, composite numbers. Okay, so in prime numbers, the basic definition of prime numbers is that these are those numbers, those natural numbers which are divisible by only one and itself, right? So let's take the example of 5. Now if we factorize 5, the only numbers which will completely divide 5 without leaving a remainder are 1 and 5 itself. Therefore 5 is a prime number. The other examples of prime numbers are 2, 3, 7 and so on, right? So there are actually there's an infinite number of prime numbers. As compared to prime numbers, the composite numbers are those numbers which will have at least one factor more than 2, right? So every number you would know have at least 2 factors. This is excluding 1, right? So let's take the example of 6. Now if I have to list down all the factors of 6, then these are 1, 2, 3 and 6. Now we notice that every number is divisible by 1 and 6, right? And itself, and 6 having at least 2 more factors other than 1 and itself will be called a composite number. Now prime and composite, both of these definitions, they will exclude this one special case, the number 1. The number 1, right? Number 1 will fall in a category which is neither prime nor composite. So number 1 is in a category of its own. Okay, so prime numbers will have exactly 2 factors. Composite numbers will have at least 3 factors. Only 1 is a number which has just 1 factor, right? Now after prime numbers and composite numbers, let's look at perfect numbers. Now perfect numbers are unique in the sense that the sum of their factors excluding the number itself is equal to the number, right? And we've taken this example 6, and 6 surprisingly is such a perfect number. So we notice that 6 has these factors 1, 2, 3 and 6. Now if we take the factors of 6 excluding 6 itself, these are factors of 6 are 1, 2 and 3, and when you add these factors, right, the sum is again the number itself. Such a number is called a perfect number. Another example of a perfect number is 28. Now if I list down all the factors of 28, then these are 1 multiplied by 28, that's the first pair, 2 times 14 is the next factor pair, then 4 times 7 is the next factor pair. Now let's leave 28 out. So we have 1, 2, 4, 7 and 14. When you add them up, they will be equal to, their sum will be 28, right? So this is another perfect number. So there are very few perfect numbers which are known, but this is you know what it is about the perfect numbers. All right, now let's move on to integers. Now in terms of integers, we know that integers are all the natural numbers and 0 and all the negatives of all the natural numbers, right? So the integers will look something like this. So we have 0 here, and we have all the natural numbers here continuing all the way till infinity, and we'll have all the negatives of all of these natural numbers continuing again until negative infinity, right? So these are this set of numbers is called integers. Now when we study integers, it is important to know the difference between the positive integers and non-negative integers, because this is something that confuses quite a few students. So it is very important to understand the difference between positive and negative integers, and to understand that difference we should understand where 2 lies on the number line, right? So 2 is actually, so we have all the positive integers starting from here and continuing all the way to infinity. So these are all the positive integers, but we have all the negative integers starting all the way from here, right? But 0 interestingly lies on neither positive side nor the negative side, right? So let's say if I have to list down all the positive integers, then they are going to be 1, 2, 3 and continuing until infinity. These are all the positive integers. But look at non-negative. So for non-negative, so sorry, this should be non-negative. So for non-negative integers, I should not only, so out of all these integers, I should exclude just the negatives to arrive at the non-negative integers. So you notice that if of all the integers I exclude out the negative integers, then I'm actually left with all the positive integers and 0, right? So the difference between positive and non-negative is that non-negative will have 0 also, okay? Similarly, there is this difference between the negative integers and the non-positive integers. Non-positive integers, right? The difference is exactly the same. So negative integers are here, -1, -2, -3 and so on. So I'll write these here, right? But non-positive, they are all the integers excluding all these positive integers. So I'm left with 0, -1, -2 and so on. 0, -1, -2 and so on, right? So the difference between positive and non-negative is that of a 0. The difference between negative and non-positive is again that of a 0, right? This is something which is best remembered. Now, talking further about integers, now let's look at certain operations involving integers and how they work, okay? So in terms of operations involving integers, of course, anything 0 is an additive identity. You add anything, you add 0 to anything, subtract 0 from anything, it doesn't give us anything. But what happens when a positive number, which I'm going to represent by a p, and a negative integer, right? A negative integer, which I'm going to represent by an n, when they interact, when there are mathematical operations around positives and negatives. So let's see what happens. So when we add two positive numbers, one positive number represented by p, the other represented by p also, please note, I do not intend them to be the same, right? So these are not variables, these are just representative of two different positive numbers, okay? So if I add a positive number with a positive number, the result is going to be a positive number. That's not a problem. But if I subtract a positive number from a positive number, the answer I don't know. Why? Because if the magnitude of this number is larger than the magnitude of this second number, then the answer is positive. If the magnitude of this number, however, is greater than the magnitude of the first number, my answer is going to be negative. If the magnitudes of both of these numbers is going to be equal, then my answer is going to be 0, right? So we don't know what happens when a positive number is subtracted from positive number. But if two positive numbers are multiplied, then the answer is definitely positive. This is not a problem. Similarly, when two positive numbers are divided, again the answer is positive. Now this may not be an integer, we can't say, right? That depends on how these are, how many common factors there are and so on and so forth, divisibility and stuff. But the net result will anyway be positive. Now let's see what happens when these operations are done on negative numbers. So a negative number, when added to another negative number, the result is going to be a negative number, right? That's not a problem. However, if a negative number is subtracted from a negative number, then we don't know. And that's because if the magnitude of this number is greater than the magnitude of this number, then the negative and negative becomes positive. The answer will be positive. If the magnitude of the first number is greater than that of the second number, then the answer remains a negative, right? If the magnitudes are equal, the answer remains 0. So I can't really say when this operation is done. However, if two negatives are multiplied, then my answer is always going to be positive, right? Because the negative sign here and the negative sign here are going to make it positive. Similarly, when a negative number is divided by another negative number, the answer is still going to be positive, right? Because the negative sign and the negative sign will cancel each other out. Alright, now let's look at operations involving both a positive and a negative number. Now when you add a positive and a negative number, we don't know the answer, right? Because the answer depends on whose magnitude is greater. But if a negative number is subtracted from a positive number, then this negative number with a negative sign becomes a positive, so the answer is always positive. Likewise, if I subtract a positive number from a negative number, right? So this is negative, and now this whole thing actually becomes a negative, right? So my answer is going to be certainly a negative number. When I multiply a positive and a negative, the answer is always going to be negative, right? Because this has a negative sign, this doesn't, product becomes negative. When I divide a positive and a negative, right? Either I divide a positive by a negative or I divide negative by a positive. In both cases, my answer is going to be a negative number, right? That's not going to change. Now let's look at powers of positives and negatives. Now in terms of powers of positives and negatives, if let's say we have a positive number whose power is another positive number, the answer is going to be positive. This is not a problem to imagine. But what happens when the power of a positive number is a negative number, right? Now let's take the example of, let's say, 5 to the power minus 3, right? Now we notice that this is a positive number whose power is a negative number. However, you should take a look at our chapter on surds and indices. A negative power just means that we take it into the denominator. We take the whole thing into the denominator. So if 5 to the power minus 3 equals 1 upon 5 cube, right, then this is still positive, right? So it doesn't matter if a positive number has a negative power, the answer is still going to be a positive number, okay? However, it is interesting to see what happens when the base is negative and I take its powers. So when the base is negative, right, and I take a positive power, it doesn't mean much until I know what this positive number is, and I'll explain why this happens. Now let's look at this example. Let's take a negative number, let's say minus 5, and give it a positive power, right? I've given it a power 2. Or let's take the same negative number and this time give it another power, right? Now what happens in this case, right, is in case you give it an even power, it's going to become a positive number, right? But if you give it an odd power, it's going to remain a negative number, right? So this thing is quite meaningless. Just telling me whether just telling me the sign of the power is pretty meaningless for a negative base. What you need to tell me is whether the negative number has an even power or whether the negative number has an odd power. So if the negative number has an even power, my result is going to be a positive number. Otherwise, my result is going to be an even number.